Have you ever touched a hot pan and burned yourself? How about warmed yourself in front of a nice campfire on a cold night? Ever notice that most of the time air vents in houses in the north are on the floor, while in the south they're on the ceiling? These are all related to the movement of heat and how it gets transferred between substances and locations. Heat can move between objects or spaces, and there are three main ways it does this: conduction, convection, and radiation. Let's look at how each one works. If someone pours you a hot cup of coffee, you're likely going to pick it up from the handle instead of around the main part of the mug. This is because the coffee mug will conduct heat from the hot liquid inside to your hand. This direct transfer of heat from one object to another is called conduction. The coffee mug transfers heat well, as do many other substances, including metal. You certainly wouldn't touch a hot metal pan on the stove or hold a nail over a flame without some sort of protective glove, because you know that the heat from the metal will quickly transfer to your hand and burn you. It makes sense then that these substances that conduct heat well are called conductors. Some substances are very bad at transferring heat, and these are called insulators. Wood is a very good insulator, therefore a very poor conductor, which is why your metal pot on the stove may have a wooden handle. You can do a little experiment to see this in action. If you have an area in your house where wood floor meets some tile, put a bare foot on each one. You'll find that the tile floor feels cooler, but both floors are actually the same temperature. The tile is a much better conductor of heat than the wood, so it transfers the heat from the bottom of your feet better than the wood does, making your foot feel cold. Air is also a very poor conductor, which is why you can reach your hand inside an oven to grab a dish without burning yourself, unless you forget your oven mitts and grab the dish itself. Your house is insulated with something like rock wool or fiberglass because these substances are poor conductors of heat. Imagine how cold your house would be if there was no protection from the cold outside during winter, or how hot it would be if you weren't protected from the heat outside in the summer. Interestingly though, insulators don't actually stop the flow of heat, just slow the transfer considerably. That's why you still need to run your heat in the winter and AC in the summer, just not as much as if you had no insulation at all. Remember how I said houses in the north commonly have their air vents on the floor, while houses in the south have theirs on the ceiling? This is due to the way that heat flows in fluids, and both gases, like air, and liquids, like water, are considered fluids because of the way they move. When heat is transferred by currents in a fluid, this is called convection. Convection happens in all fluids, like the air in your home, water in a lake, and magma underground, just to name a few. Here's how it works. Imagine a room full of children who have just had a bunch of cookies. They become quite energetic and start running around the room. If you open the door and let them outside, they burst out and start running around the larger space, spreading out in the yard. The same thing happens when a fluid is heated. The molecules at the bottom gain energy and begin to move faster. As they move faster, they begin to spread apart, which makes the fluid less dense. But instead of being confined to a yard, the fluid's warmer molecules begin to move upward while the cooler, denser fluid begins to sink, just like the children start settling down as their cookie rush subsides. Once the cooler molecules reach the bottom where the heat is, it's like they ate another cookie and get an increase in energy again. They rise back up to the top while the cooler molecules sink back down to the bottom. The cycle continues as long as there is a heat source at the bottom. What does this have to do with air vents in a house? Well, if you live in a cold climate, you probably use your heat more often than your AC. And if you live in a warmer climate, you probably use your AC more than your heat. So if hot air rises and you use your heat more often, you'll want your vents on the floor so that hot air travels upward to fill the room as it comes out of the vents. The opposite is true for air conditioning. If cool air sinks, you wouldn't want it to start out on the floor because it wouldn't cool the room as effectively as if it starts from the ceiling, where it can cool the room as it falls. When you sit in front of a campfire, you're warmed by its heat. Hover your hand over a hot light bulb and you'll feel the heat coming off it, even without touching it. Stand out in the sunshine and you'll quickly get warmed by its rays. These examples illustrate our final mechanism of heat transfer, radiation. Radiation is when heat is transferred by electromagnetic waves like radio waves, infrared waves, X-rays, and even visible light. All objects both emit and absorb radiant energy, even you. Though, like everything else, some objects and substances are much better at this than others. Those that are good at emitting radiant energy, like the sun, are also very good at absorbing it. A radio antenna is designed to be a good absorber of radio waves, but that also means it's very good at emitting them. When it comes to radiant heat, much of what is produced on Earth comes from the Earth itself. It absorbs radiant energy from the sun and then emits it back towards space. This radiant energy emitted by the Earth is called terrestrial radiation, and it is what makes life possible. Like a big blanket, gases in the atmosphere trap terrestrial radiation on Earth and keep our planet nice and warm. What's really interesting is that unlike conduction and convection, radiation happens even when there is no material for the heat to travel through. The sun's rays travel through space to Earth, but since space is by definition empty, there's no point of contact, like conduction, or fluid, like convection, for the heat to travel through. The waves simply move heat through space just by, well, moving. Heat is very friendly. It likes to move, transfer, and travel. It does this by three main mechanisms: conduction, convection, and radiation. Conduction is the transfer of heat through direct contact between different objects or substances. Touching a hot pan on the stove, walking on hot sand along the beach, and putting a metal poker into the fire are all examples of conduction because heat is transferred from one object to the other as they touch. Some substances are better at transferring heat than others, and to make it easy, these are called conductors. Substances that do a poor job of transferring heat are called insulators. Metals are good conductors, but things like wood and air are poor conductors. If you put your hand in the oven, it doesn't burn, but grab the dish that's been heating in there, and I bet you'll wish you had your oven mitts on. And remember, you still have to use your heat in the winter and air conditioning in the summer because insulators don't stop the transfer of heat, they just slow it down considerably. When heat is transferred through the movement of fluids, this is called convection. Convection currents are like the result of giving children cookies. The molecules at the bottom have more energy and are warmer, so they move to the top of the fluid. Meanwhile, the molecules at the top are cooler, they're coming down from their sugar rush, and sink back to the bottom where the cycle starts all over again. Both gases and liquids are considered fluids, so you'll find convection currents in air as well as water. When heat is transferred by electromagnetic waves, this is called radiation. These waves come in all forms: X-rays, ultraviolet, radio waves, and even visible light. Like heat radiates from a fire or a radiator in a house sends heat out into a room, radiation is the movement of heat from one place to another simply by traveling along with the waves. All objects both absorb and emit radiation, though some are better than others. The Earth is very good at both absorbing and emitting the sun's radiant energy, and when it sends it back into space, this is known as terrestrial radiation. Terrestrial radiation is what makes life possible on Earth. This is because as heat is radiated back towards space, it gets trapped by the gases in the atmosphere, making Earth a nice, warm place to live.